this video I'm going to explain the calculation of a final trim because of loading. So here we have this vessel where the forward draft is 5 meter and aft draft is 7 meter. Well, I have used the simple numbers so that we can understand the concept. And the length between perpendicular is 100 meter. I have this 100 ton weight. Well, this 100 ton weight is loaded somewhere here, where the distance from midship is 42 meter, or simply we can say the HG is 42 meter. So we know the center of flotation is given, which is 2 meter forward of midship. So this is midship H, and the AH is 50 meter because the total length of the ship is 100 meter, and the distance of this weight from center of flotation is 40 meter. We can mark this as D. D is going to be 40 meter. Now, instead of loading this 100 ton at this distance at D is equal to 40 meter, what we will assume that I have loaded this 100 ton cargo at center of flotation, which simply means that it will create a body sinkage, and the body sinkage is given by W upon TPC. Well, the definition of TPC is number of tons required to sink the ship by 1 centimeter, or number of tons required to raise the ship's draft by 1 centimeter. The TPC is immersion per centimeter. So if I have W ton, so I should know how much the ship has sinkage. So W by TPC will give me the sinkage in a centimeter. Now let us find out what is the sinkage. So this, we have taken the TPC as 20 ton per centimeter. So we have W is 100 and the TPC is 20. So after dividing, I get 100 divided by 20, which is 5 centimeter. So we have body sinkage of 5 centimeter. This also means that the forward draft will increase by 5 centimeter here, and aft draft will also increase by 5 centimeter. Both the draft will increase by 5 centimeter. So here this is the old water line, and after placing this 100 ton at center of flotation, this will be new water line. Now let us work on trimming moment. Well, trimming moment is W into D, where W is the weight and D is the distance from center of flotation. And we take this center of flotation simply because the F is the pivot point. Center of flotation is the point where the ship has to trim about. So W into, so I have this trimming moment 100 is the weight and 40 is the distance from center of flotation. So I have 4,000 ton meter, and the direction will be by head because I have loaded this 100 ton in the forward direction. Now let us find this trim cost. Well, trim cost in centimeter is trimming moment by MCTC. The concept of trimming moment and MCTC is also similar to the TPC. MCTC means moment to change the trim by 1 centimeter. So if I have the total trimming moment of 4,000 ton, and if I divide that by MCTC, I will get the trim in a centimeter. So I have this 4,000 ton meter trimming moment, and I divide this by 200, which is my MCTC, and I have taken the value of MCTC as 200, so I get 20 centimeter trim cos. By the way, this trim cos will be in the forward direction because the trimming movement is also by head. Now, if TF was the change in the forward draft and TA was the change in aft draft, or change in the trim forward or change in the trim aft, so we know that the trim cos, the total trim cos will be TA plus TF, and the TA is given by AF divided by L into TC. Now, since it was 100 meter, this is A, this is B. So this was 100 meter, so H is going to be 50, and F is somewhere here, which is 2 meter, so AF is 52. So 52 divided by 100 multiplied by 20, which is trim cost, so I get 10.4 centimeter. Now the trim forward, the change in the trim forward will be 20, which is TC, minus TA 10.4, which is 9.6 centimeter. Now let us work to find the final draft. So first let's write the initial draft, and initial draft forward and aft. Forward was 5 meter and aft was 7 meter, and it is much better to write in 3 places. So first of all, there is a body sinkage, and we have calculated body sinkage as, first of all, there is a body sinkage, and the body sinkage was W by TPC. The W was 100 ton and the TPC was 20, which gives me 5 centimeter. And after converting this 5 centimeter into meter, which is I need to divide by 100, I get 0.05 meter. So the body sinkage has to be added in both the draft. Now let us apply the TF. TF is 9.6, and this is the change in the forward draft. So let me apply this change in draft, and the forward is 0.096 and the aft is 0.104. TA is 10.4 centimeter, or I convert this in meter, so it is 0.104. Well, just to check the sign, the change in the draft, that TC was forward or by head, that means this forward draft will increase and aft draft will decrease because we had loaded the cargo in forward direction. So the forward draft will increase, so the TF will increase. So I use this sign, so I have to add this forward draft, change in the forward draft positive, and change in the aft draft has to be negative. So I get the final draft as 5.146, 5 plus this, and aft draft will be 7 plus this minus this. So this is my aft draft. Just for sake of cross check, we know that the initial trim is 2 meter by stern. The trim is the difference between forward and aft draft, so 7 minus 5, that is 2 meter by stern. Why by stern? Because the aft draft is more. Now the final trim is 1.8 meter by stern. Why? Because 6.946 minus 5.146 will give me 1.8. So my trim from 2 meter is reduced to 1.8. That means my trim cost TC is 0.2 meter by head or 20 centimeter by head, and that is what we had exactly calculated here. The trimming moment was 4000 ton meter by head, and trim cost was trimming moment divided by MCTC, which was 20 centimeter, and the direction has to be by head because the trimming moment is also by head. So that serves as a cross check as well about this problem. Let me come down here. So this serves as a cross check as well.